The last type of question we're going to look at is a tricky normal question. And we call it tricky normal because we are either not given the mean or not given the standard deviation, which means that we're actually going to have to use the z-scores in this scenario. We're going to have to use the z-score formula at the end to convert it to an x value. So in our first example, we have a mean of 20. And we also know that we have 25% of our data above 22, but we don't know what our standard deviation is. So let's draw our curve, put in everything we know, so our mean in the middle of 20, and we know there's 25%, so 1/4 of our data is above 22. So we're going to put in 22 and we're going to label the area under the curve. So since we don't know the standard deviation, we are going to have to convert these values to z-scores, which means that 20 would be associated with our mean of the standard normal distribution, which is 0. And then our 22 is going to be changed to a z-score. In order to find the z-score that corresponds to the top 25%, we have to use the inverse norm function, and we're going to use the area to the left, which is 1 minus 0.25 or 0.75. So using the inverse norm, and again this can be used on the calculator or on StatCrunch, we're simply going to put 0.75 as the area to the left. We have to use the 0 and 1 because we cannot use the normal distribution because we don't know the standard deviation. So this requires an additional step over here. Let's do this on our calculator. Go to second vars, inverse norm, using an area of 0.75 to the left with a mean of 0 and a standard deviation. Put this up a little bit, hold on. And a standard deviation of 1, which is our standard normal distribution. This gives us a z-score of 0.67. Usually z-scores are rounded to 2 decimals because that's what the table gives us. There's a couple of values that are commonly rounded to 3 decimals if they're right in between 2 values. So now we're going to look at our z-score formula. So z-score is x minus the mean divided by the standard deviation. Oftentimes we change this formula and actually solve it for x, which makes it a little easier. So in order to do the basic algebra to convert this formula, we would first multiply both sides times sigma, and then we're going to add mu to both sides. So we end up with a formula that z times sigma plus mu is equal to our x value. And this one is usually a little easier to plug in. So let's see all the things we have. So we calculated our z-score that was associated with the bottom 75%. We also have an x value over here, and we have a mean given. So we're plugging in all those values. Our z-score was 0.67. Our sigma is unknown, and our mean is 20, and our x value is 22. So solving this for sigma, we're going to subtract 20. We have 0.67 times sigma is equal to 2. And then we're going to divide both sides by 0.67. And we end up with a sigma equal to 2.99. All right, our second question is going to be very similar. However, this time we are not given our mean. So again, we're going to draw our picture. We don't know what the mean is, so we're just going to put mu there. We know that 20% is below 100. So that means the bottom 20% over here corresponds to 100. And we know our standard deviation is 15. So same procedure as before. We're going to use our TI-84, or we could use StatCrunch in order to find that value that corresponds to the bottom 20%. So we're going to use the inverse norm function of 0.2, 0, and 1. So over here it's very important whether we use StatCrunch or whether we use the TI-84. We want to make sure that we're using the standard normal distribution. And I can show you this example on StatCrunch just to kind of mix it up a little bit. So we're going to go to the standard curve. We are looking at a standard normal distribution with a mean of 0 and a standard deviation of 1. We're looking at the bottom 20%. We're going to hit compute. This gives us a z-score of negative 0.84. And we can label this over here on both sides. Again, we're going to use that second formula, which was that x is equal to z times sigma plus our mean. X value over here in our example is 100. Our z-score we calculated was negative 0.84. Sigma was given in this question, and all we are trying to find is our mean. So let's multiply negative 0.84 times 15, which is negative 12.6. And then all we have to do is add 12.6 on both sides, and we end up with 112.6 is equal to our mean.